Hi everyone, welcome back to Java 1 for All. In this video, we are going to talk about parallel streams. We didn't talk about threads, but we don't need to understand completely threads to be able to understand how parallel streams work. So just copy the class and let's rename it to 16. Just clean up a little bit and let's get started. So we have been working with only one thread. The thread is called main. How do you know the name of the thread you have been working on? Thread dot current thread dot get name. So we are going to talk about threads later, but all the threads that we have been working so far is this main, only one thread. You can think of thread as a worker, the worker that's responsible for running our program. Now we are executing strings all the way through these 15 classes, and in each one of them we only had one worker. So everything that we were doing, all the grouping, all the averaging, all the summarizing, was done by one worker, one thread. But usually the processors, they have more than one. For example, if you print here runtime.get runtime.get not the get, but available processors, it shows you how many threads you have available. Of course, you can create more. In my case, I'm running a 4th generation Intel. It has 4 cores. Usually the number of threads is double the number of cores. So we have 4 cores in my case, and then I have 8 threads. You can create virtual threads, but well, we are going to talk into details later, but it's not always a good idea. So usually when we are working with parallel streams, by default they will use the 8 threads. It means that the parallel streams will have 8 workers to do the work that they have to do. There are some cases where using parallel streams is a good idea, and there are some cases where using parallel streams is a bad idea. Right now, I'm just going to give you a simple example, and then in the next video, I'm going to show you things that you should watch when you are using parallel streams. So let's start with something very simple. Let's give here a long num, and let's say that we have 10 medium. And I will create here some methods that will sum. Private static void sum, and I will start with a simple for. Let's add the name of the method here, and then let's just add a long result, and then let's get the time to see how much time it took to do this math. And then for long I, starting with 1, I lower or equals the number I plus plus. Okay, so now I'm going to get result plus equal I. Now long and let's print here the result plus, give one space here, and minus init, and this will be in milliseconds. Control Shift F10. Oh, actually I forgot to call. Let's call here sum for, passing this num. Okay, so doing this simple math using the for, we have everything done in 7 milliseconds. So this is pretty fast, and the reason is that the for was created for these kind of things. It works very close to the low-level machine code, and you will almost always get a very good performance when using fors. And what happens if we move to string? So let's copy this, and let's use what we know, sum string iterate. Copy this. Okay, so let's remove this for, and let's call string.iterate, and then we are going to start with 1, and then I plus 1. And then the limit will be the number, otherwise it will keep running forever, and then reduce to long sum. So I'm going to introduce a local variable. I will call it result. Well, I will just copy this one here, and then I will remove this one here. Okay, so basically we are doing exactly the same thing. Just need to add a semicolon. And let's see the results. Control Shift F10. And we have very long time if we compare to the regular for. So as you can see, even though we are using one worker for both of them, the performance for the for loop is way better than the iterate. The problem here with iterate is that we first we have to go doing the wrap and unwrap for each one of them. We saw that we can work with long string, and we are going to get there, but just so you can see the difference between the for and the iterate, it's huge. If we increase this number a little bit more, you are going to see an even more greater difference. Okay, so what if we just try to parallelize this? I want to have like multiple workers doing the same thing. It's very simple, and the whole idea about the parallel strings was to abstract the complexity of working with multiple threads, because it's very complex from the developer. So when we want to have parallel streams, basically we just want to delegate. For example, let's say that we have 10 numbers, 1, 2, 3, up to 0. So when we say that we would like this to run in parallel, the sum of these numbers, we can say, for example, okay, the thread 1 will be responsible for summing the numbers from 1 to 5, and maybe the thread 2 will be responsible for counting the numbers 6 and 7, and thread 3 will be from 7 to 0. So it's impossible for you to know how things will work behind the scenes. There is no way for you to control that. So you just have to accept that you have multiple workers working in the same source of data. And how can we do this right here? It's pretty simple. You just have to add somewhere in between the intermediate operators the call to parallel. So you can open here to see we have this as parallel, and we have different ones. We're going to see later on when we use this one, but basically this method is going to tell, hey, this string should run with multiple threads. You can add it here, or you can even add after the limit. The order will not matter in this case. So let's execute this one. Let's see. Control Shift F10. And as you can see, we have even more time. So it looks like working with parallel strings is not worth it. Well, you have to be careful, because not everything will work better with multiple threads. In this case, when we are iterating, it's not like what I did here. Java doesn't know like the amount of numbers that it needs to run iterating through. We have this limit, but it's not like you already have the range. And since it does not have the range, like the threads, they get lost. They don't know. For example, okay, so I don't know how many numbers I have. I just have to start giving to different threads different numbers range. So it's complex because you are going one by one. If we increase this number, as you can see, things start getting even longer to process. And the processor, it goes crazy. So for example, if I execute again, Control Shift F10, you'll probably see the CPU going almost close to 100%. So in this case, I have like 4 threads. You can see that we have 2,400 using. Most of this is because of the operating system, but the logical processor that I have is 8. So the number of cores that I have is 4. Okay, so how can we improve this? So one way of improving is first stop wrapping and unwrapping. This will increase the performance. For example, let's copy this one, not this one, let's copy this one. So let's use long string ranged closed. So basically here I'm going to use long string range closed, and I want from 1 to this num. I'm going to return remove the limit because we don't need anymore, and we are going to keep the reduce. So let's see, this is just using one thread, not parallel strings. Let's see, Ctrl Shift F10. So as you can see, just by using the correct string, the value decreased from 1 second to 157 milliseconds. Now let's see how this works with parallel strings. Now, let's copy this one, go all the way up, Ctrl D, Ctrl V. Okay, so let's see how this works. Ctrl Shift F10. As you can see, it took 25 milliseconds. In this case, it was even faster than the for loop. And why was it faster? First, because we are not wrapping and unwrapping the double. And second is because Java knows the amount of numbers. So basically, it can give the correct values for all the available processor, available threads that it has at his disposal. So this is it for parallel string. In the next video, I'm going to explain things that you should be aware and what you should look for when deciding to use parallel or not parallel strings. So see you in the next video. Bye.